How do you pick a welding positioner? Wrong choice, and the robot can be dead accurate, yet the cell never hits cycle. Three numbers are the real gate: payload, turning torque, and indexing accuracy. First, payload, workpiece plus fixture. EVST's single-axis EVS-SWP covers 200 to 2,000 kilograms. The dual-axis EVS-DWP family goes to 5,000 kilograms. Pick the class above your max part weight with a 30% safety margin. Second, turning torque. This decides acceleration. Enough payload, but not enough torque, and the part rotates slowly. Torque scales with eccentricity times weight times angular acceleration, so it can't be inferred from payload alone. Third, indexing accuracy. This directly decides where the seam lands. The robot's seam tracking holds plus or minus 0.5 millimeters. The positioner needs better than plus or minus 0.3 degrees of indexing accuracy not to eat that margin. 5 layouts to choose. Single-axis turntable for flat parts. Dual-axis L-type for 3D parts. Headstock-tailstock for long shafts and pipes. H-type for 2-station throughput. Ferris wheel for dense small parts. 2-station layouts roughly double arc on time. While the robot welds one side, the operator loads the other, so welding and material handling run fully in parallel. How does it pair with a travel rail? Long seams over 2 go with W500, W800 rails to extend reach, and both join the robot controller as coordinated external axes. No point lost, no cycle stretched. Picking a positioner isn't picking a turntable. It's picking a partner that locks seam accuracy with the robot and parallels the operator. This is EVST. We build the positioner as the robot's second hand.